Hello everyone, welcome back to Smart Edu's YouTube channel. My name is Ankit Patel and I'm again back with one more Codeforces contest post discussion. In this today's video, we are going to see Codeforces Round 952 problems. It is a before contest, so initial few problems will be easy. So let's dive into the first problem, that is creating words. Here it is given that Matthew is given two strings A and B, both of length 3. Matthew is having a two strings A and B of length 3. Okay, length 3. He thinks it's particularly funny to create two new words by swapping the first character of A with the first character of B. He thinks it's particularly funny to swap the first character of A with the first character of B. Something like this. Now he wants you to output A and B after the swap. After swapping, he wants you to print the A and B. I hope question is pretty straightforward. Nothing much to explain here. One more note is also given. Note that new words may not necessarily be different. He is saying that after swapping, A and B can be same as well. Okay, it is not necessary that they will be different. Now let's look at the test case input format here. First line will be test case. Number of test cases will be given. After that, for each and every test case, two strings will be given, A and B of length 3. String will be containing only the lowercase letters. Output format. For each and every test case, we need to print the A and B after the swap, separated by a space. Okay. Let's try to look at the example. But before we see the logic and everything, just pause the video. Okay. Try to think of a logic. Once you get the logic, try to code it up. Okay. Let's try to see the example here. First one is A string is something like bit and B string is something like set. And Matthew, he particularly finds if we swap the first character of A with the first character of B, something like this. That means here S will be coming and here B will be coming. That means string A will be sit and the string B will be bit. And if you look at the output as well, it is sit and bit. So we need to swap the first characters of A and B and we need to directly print it. If you look at the fifth test case as well, cat and cat. So here string A is something like cat, string B is also cat, and if I swap them, like if I swap the first character of A with the first character of B, it will be again cat only. Like string A will be cat, string B will be cat. Both will be same. Now just think of how can we swap the two characters. How can we swap two characters? One thing is we can use the swap function that is there. Another thing can be if we don't want to use the swap function, we can swap it using the three variables. I hope you know that how to swap using the three variables. We'll be taking a temporary variable. We'll be storing like in that we'll be storing the first character of A. Now I'll be saying that make the first character of A equals to first character of B. Now I'll be saying first character of B equals to the temporary character. And if you want to know how do we swap using the third variable, it will be something like, let's take here the maybe the second test case. A is cat, okay. B is dog. If we go through this logic, what will be there in our character ch? Nothing but A of 0 means character C. Now what I am telling, in the A of 0, that means in this position, in swap it with the not swap, have the B of 0. What is B of 0? Nothing but D. That means here first will be having the dat. Now I will make the string A as dat. Now in the here in this line what will happen? Now I will be inserting B of 0 equals to ch. So what is B 0th index? D. So I will be replacing this with the character ch. What I am having in character ch? Nothing but the C. So my string A will become dat and string will becomes cock So if you look at the output as well, if we print, we'll be getting the data and call. I hope this is pretty straightforward. No, we can directly code it up. We can go to the coding part. Okay, this was the entire problem. Let's try to code it up. What all given in the test cases? Okay, number of test cases for each test case, two strings A and B. Already I have read the number of test cases. Directly I will be taking A and B, string A comma B. After that C in A B. Now I need to swap. I can use the swap function as well. A of 0 comma B of 0. Or if I don't want to do so, what I can do is I can use the temporary variable here, where I will be first storing A of 0. Next I will be telling A of 0 equals to B of 0 and B of 0 equals to CH. At the end I can simply print A and B separated by a space. Okay, let's try to run. If I look at the sample output, last two are same. Sit bit dat cop. Yeah, it is same. So I will simply submit creating words and I will submit it. Actually, I have submitted the same solution, so I will submit here with something else, and it is accepted. That's it for the first problem. Okay, let's look at the second problem, that is maximum multiple sum. In this problem, you are given an n. We need to find an integer x. Okay, given an integer n, we need to find an integer x here. Few conditions are given. We need to find the x such that x is greater than or equals to 2 and x has to be less than or equals to n here. Basically, first condition. If you look at the second condition, that is the sum of multiple of x. What could be the multiple of x? Multiple of x is nothing but x, 2x, 3x, so on, some kx. Okay, these are the multiple of x. So he is saying that sum of multiple of x, sum of multiple of x that are less than or equal to n is maximum. That means here we'll be taking only the multiples that are kx. We are taking until less than or equals to n only. Okay, we need to maximize this. We need to maximize this thing. Formally, x plus 2x plus 3x on kx, where kx is less than or equals to n, is maximized over all the possible values of x. Okay, same thing that I have explained here. Now we need to find this x here. We need to find a x which will give the maximum sum. Okay, we need to find a x which will give the sum of multiple of x that are less than or equals to n will be maximum. Okay, what are the values of x? Values of x will be starting from n. It will be going till starting from 2 going till n. We can apply 2 in this, we can apply 3 in this, we can apply 4, we can apply till less than or equals to n. Whichever is giving the maximum sum, we need to print that. I hope question is straightforward here, like very straightforward question. If we look at the sample input here, what is given in the sample input? Number first line will be nothing but number of test cases. After that, in each and every test case you will be given an n. For each and every n, we need to find the x. Okay, before we move further, see the logic and everything, just pause the video, try to figure out the logic on your own, read the question 2 to 3 times. Okay, once you get the logic, try to code it up. Now let's see the logic here. Okay, if we look at the first example, when n equal to 3, what are my possible values of x here? Can I say that if you look at the condition for x, what is that? It has to be greater than or equal to 2 and it has to be less than or equals to 3. So can I say that my possible values of x are nothing but 2 comma 3. Now let's say I'm applying 2 here. I'm applying here 2. Let me get this. somewhere here so that I won't have to repeat again and again same thing here. Okay, now let's take I'm applying 2 in this logic. What will happen? I will only be getting 2. Next multiple will be 4, but 4 is greater than n. So I won't be considering 4. I will be taking only 2. So here for x equal to 2, my sum will be 2. Okay, let's try to apply 3 here. We can apply 3 as well. Again, I can simply apply 3 here. 2 into 3 will be 6, but it will be greater than n. So I cannot take this as well. So here my sum will be only 3. Out of 2 and 3, which is maximum? 3 is maximum. Yes or no? So here 3 will be the output. X equal to 3 will be giving the maximum sum of multiple of x. Let's try to see the second example as well. Then it will be somewhat more clear for you. Second test case here, n equals to 15. That means what are my options for x here? I can take 2, I can take 3, I can take 4, I can take 5, so on up till 15. Yes or no? Now let's try to do the same thing. Let's apply 2 in this condition here. What it will be? It will be our sum will be something like 2 plus 2 into 2 plus next multiple will be 2 into 3. Next multiple will be 2 into 4. Till when I will be doing? Till it is less than or equals to 15. When it will be less than 15, nothing but 2 into 7, which is nothing but 14. Next multiple will be 2 into 8, 16, which will be greater than n. So we won't be considering. And if I find the sum of all these numbers, it will be nothing but 56, which is given here. According to the here explanation, value of 2 will giving me the maximum sum here. Okay, for 2 we are getting 56. Let's try to do it for the 3 as well. Okay, we will be doing for the 3 as well. Okay, I can see someone here. Let's try to find it for the 3 as well. Sum 2 here, it will be 3 plus 3 into 2. Next it will be 3 into 3. Next 3 4s are 12, 3 5s are 15. That's it, I guess. We cannot take the next multiple because next multiple will be 18, 3 6 are 18, which is greater than 15. And if I try to find the sum of it, it will be something like 3 plus 6 9, 9 plus 9 18, 18, 18 plus 12 20, 30, 30 plus 15 45. Yes or no? And if you look at the number of multiples here, how many multiples? Like 1 multiple, 2 multiple, 3 4 5, like multiplied with 5 6 and 7. Here there are total 7 multiples. Here if you look at, there are only 5 multiples. Yes or no? Total 7 multiples, here only 5 multiples. You can try it for the 4 as well. But when you try for 4, what you will be getting here? When you try for 4, it will be like 4 plus 4 2s are 8. Next 4 3s are 12. That's it, I guess. Because 4 4s are 16. Now here if you try to find out the sum, it will be something like 8 plus 4. 8, 8 plus 12 will be 20, 24, which is even lesser. So if you look at down the line when we are going, what is happening here? Sum is also reducing. Sum is also getting reduced. But that thing we cannot say for sure, because if you look at maybe like sum 4 equal to, I'm taking 5, so it will be like 5 5 2s are 10, 5 3s are 15. So it will be something like 15 plus 10, as I said, 15 plus 10 25, 25 plus 5 30. Yes or no? Which is greater than like sum 3. But if you look at what is happening here, number of multiples here are again 3, like 3 multiple here also we got the 3 multiple. I can sure that 2 will be giving the maximum answer. Okay, there will be some mathematical proof as well. Okay, you can read about that, but here I can say that 2 will be giving the maximum, because when you go down the line, one thing is there for sure, that multiples will be reducing, number of terms or number of multiplication will be reducing. Okay, But now you can say that it is failing for 3. Okay, you can consider 3 as a base case here, edge case you can say. Okay, let's have some values for n here. That is 2, 3, 4, 5, 6, 7, 8, maybe so on. Now if you look at for n equal to 2, answer will be 2. For n equals to 3, answer will be 3 here. But apart from this, for everything, answer will be 2 only. This is the one of the observations you can make here. See, the observation is the one part of the logic. Like we can make the observation and we can write the logic. Or you can do the other thing as well. Why don't we write the entire whatever is given in the question? Do the same thing. We can do the that thing as well. This is like one of the things. Second thing can be whatever is given in the logic, do the same thing. Write a for loop. In the for loop, like go from 2 to go from 2 to n. In each and every n, what I will be doing, I will be initializing my sum equal to 0. Now another loop or something where I will be multiplying each and everything. 2 equals to every time it will be like something like I will be saying my number equal to or x equal to 2 here, and every time it will be something like x equals to x into how much, x plus I here, something like this. Like initially if I take I equal to 3, I will start from 3, but if I take example as 3, like I equal to 3, it will be 3, next it will be 3 plus 3, next it will be like 3 plus 3 plus 3, so on. So we can do this as well. After that I can say my if my sum is greater than whatever the max sum, I can store I can have my result equals to I, something like this. We can do this as well. So this is the entire logic. Like if you're writing whatever is given in the question, this is the thing. But if you make an observation, this will be the observation. Apart from 3, for each and every number of n, our answer will be 2. But for 3, our answer will be 3 only. Same thing we can write in the code as well. I will be taking n, reading the n. If n equal to 3, we can print simply 3. If that is not the case, I will be printing 2. We can take the test cases here. I can run for it. What should be our answer? 3 and 2. 3 and 2. I can copy this. I will try to submit. Maximum multiple sum. So this comes based on the observation, and for the for initial problems, edge cases will be given in the test cases only, like in the sample input only. Your edge cases will be given. So this is also accepted. That's it for the second problem. Let's try to look at the third problem, that is good prefixes. In the problem, it is given that elect thinks some array is good if there exists some element that can be represented as a sum of the all other elements. The sum of all other element is 0 if there is no elements. Okay, so elect thinks that if there is some array, okay, if there is some array, it is good, this array is good if there exists some element that can be represented as the sum of the other elements. So I can take here 1, here I can take like something like this. Okay, I can take this example. This array is good. Why this array is good? Here I can like I can take the element 10 and it can be represented as the sum of the all other elements here. If you look at the all other elements, it is 10. So one element can be represented as the sum of the all other elements. That array will be good. And if there are no elements or something like this, this is also good because some of the other elements are not there. That's why sum is 0. Here example is given. In the example array 1 6 3 2 is good. He's saying this array is good. Why? because we can represent the 6 as sum of the all other elements. Here it is also given 1 plus 3 plus 2 equals to 6. Furthermore, the array 0 is also good. As I said, array 0 is also good because this can represent the sum of the all other elements. However, the array these like 1, 2, 3, 4 and array having the element as 1 are not good. Here array with element 1 is not good. Why it is not good? Because here we cannot pick a element that will be represented as sum of the all other elements. Here as well, if I pick any element, if I pick any element here, that cannot be represented as the sum of the all other elements. I can pick 4 as well, but 4 cannot be represented as a sum of the all other elements. Now here Alex has an array. Okay, Alex has an array of elements, something like this. Like he is having an array with few elements. Help him to count the number of good non-empty prefixes of A. Okay. In other words, count the number of integers I such that the length I prefixes such, like A1, A2, so on AI is good. So he tells that he is having an array. Okay. I can take a few examples. Like we can take this example only. 1, 6, 3, 2. He want to count how many prefixes are good here. I can take this one prefix, 2, 3, 4. Is array 1 good? Is array 1 comma 6 good? Is array 1 comma 3 comma 1 comma 6 comma 3 comma 2 is good? Not 2. We will include 2 in the next one. So he want to get all the prefixes and he wants to find how many of them are good in this. So here only 1 is good. So our count has to be 1 here. Okay. Now let's look at the sample input. How the sample input and output is given. In each and every test case, like first line will be number of test cases. After that, you will be given n along with an array elements will be given. For each and every test case, we need to print a single integer number of good non-empty prefixes of array A. Okay, let's try to take few examples here. We'll be starting, let's take the third one here. Okay, but before we move further, as I always say, first try to get logic on your own. If you're able to get the logic, try to code it up as well. Okay, now let's try to logic, let's see the logic here. Example here given is array is something like this 1 1 2 0. Okay, let's try to get all the prefixes here. One of the prefixes is 1, another prefix is 1, one more like 1 1, other prefix can be 1 1 2, another prefix can be 1 1 2 0. Is this prefix good? No, it is not good. What about this one? This is good. I can pick one and it can be represented as the sum of the all other elements of the array. Okay, 1 equals to 1. What about this one? This is good. What about this one? I can pick 2. In this I can pick 2. 2 can be represented as the sum of the all other elements here. 2 equals to 2. What about here? Same thing. I can pick 2. That means this is also good, this is also good. So how many good non-empty prefixes of this array do we have? 3 here. So let's look at the sample out, like what is the output for this? 3. Okay, what call we can do here? One thing, you can get prefixes one by one, prefix. After getting a prefix, let's suppose you are having any of the prefixes here. What we can do here, maybe you will in this prefix, let's try to focus on any one of the prefixes here. Okay, let's say I'm focusing on this prefix. Now here I will be picking one. Now I will be seeing, or I will be checking, can I represent one as the prefix of, or can I represent one as the sum of all other elements here? No. So I will be moving to the next element. Now again I will be saying, can 1 be represented as the sum of the all other elements? No. What about 2? Yes, 2 can be represented. So if any element in that prefix can be represented as the sum of the other elements, I will be considering that as a good prefix here, and I will be incrementing the count. But that will be taking a lot of time. If you see the time complex here, number of test cases 10 power 4. If you look at the n, like number of elements 10 power 5. So it will be kind of like n square solution, and that won't work. Now we need to come up with something like, if I am having a prefix 112, I need to figure it out. Is there a element in this prefix? Is there a element that can be represented as the sum of the all other elements? How will I figure that? Without going brute force, without picking one by one, something like this, taking one, again take one, do something here, pick two. No, I don't want to do so. Directly want to find out if there is a element which can be represented as the sum of the all other elements here. So see, one logic can be, let's say x is the element that we are finding here, x is the one of the element that we are finding here, which can be represented as sum of the all other elements. So can I say that sum of array here, okay, sum of this array, x equals to sum of array minus x, something like this? Yes or no? We want to find x such that is sum of the array minus x will give you again the x here, and if I submit x on the left side, it will be something like 2x equals to sum of array, x equals to sum of array by 2. So we need to figure out an element, we need to figure out an we need to figure out an element. The element is nothing but sum of array by 2. That means here, if I am able to see that, or if I am able to figure out that, is there any element which is sum of array by 2? What is sum of array here? Sum of array is nothing but 4. 4 by 2 equals to 2. Is 2 present in the array? Yes, 2 is present in the array. That means this is one of the good prefix. That means I need to store, I can store from here to here everything in map. I can go prefix, like I can find the prefix, getting 4, 4 by 2, 2. 2 is present, I can check in the map. That is the one of the things. Like this is one of the logic for finding out if this is a good prefix or not. There is other logic as well. That is, let's say, let me take some other example here. 1, 4, maybe 3, 2, something like this. But we are finding the prefix still here, okay? Is there any element in this prefix which can be represented as some of the all other elements here? Okay, let's remove 2. Yes, it is 4. Now can I say that if I want to choose some x, this has to be the maximum number in prefix. It has to be maximum number in prefix. Why so? Why only the maximum number will be the x here? Because if x is not the maximum number, for sure that will not be our element that we are looking for. That will be some of the all the elements except that element. So here it is guaranteed that maximum element will be our x here in any good prefix. So I can simply check here if maximum element equal to max element equal to prefix by 2. However, in the prefix sum I will be having some, so prefix by 2 basically. That can also be done here. Okay. I hope both the logics are clear. If it is clear, we can directly go to the solution, like we can code it up. What all given in the input here, we'll copy that. Number of test cases for each and every test case. I will take n. I will be saying scene n int array of n here. I will be reading each and every value of array. Scene array of I. What all things we require? One is prefix sum. One is as I am taking the prefix sum, I will be taking it as long. I don't know if it is required, but Long log prefix sum I will be taking. What all to be required? One is prefix sum. We need to have the count as well. We'll be having count equal to 0. Okay. Now let's go element by element. Finding the okay. We need to get the max element as well. Max element equals to int min I will be saying. Okay. That's all I guess. Now I can go element by element. Int I equal to 0, I less than n, I plus plus. I will be saying prefix equal to prefix plus prefix sum equal to prefix sum plus array of I. I need to get the max element as well. Max element equals to max of max element max element equals to max of max element comma array of I. Now I will be checking if whatever the prefix sum is there, prefix sum by 2. I'm just trying to make sure that I just want to make sure that prefix equals to max element here. So max element is our nothing but x. If that is the case, I will be incrementing the count. I will be saying count plus plus. At the end, I will be simply printing the okay. See out count here and l. Okay, let's try to run. Let's try to see 1033 412. Same thing. So I can simply copy this. I will be submitting it here. Same thing. Whatever we discussed, we are doing the same thing here. Mhm. Wrong answer on test case 2. Yeah, we forget to add that key. When it is even, prefix sum equals to even, then only we can do all these things like prefix sum mod 2 equal to 0. When it is equals to 0, then only we can divide into two parts. Basically, that whatever x is there, it will be greater than or equals to like it will be equals to sum of the all other elements. We can submit it here. Again, we can try submitting it. Third solution, submit. This time it should accept. Yeah, it's done. That's it for the third one. Okay. Let's see the fourth problem, that is Manhattan circle. Given a n by m grid of consists of dot and hash characters. Okay. So in the problem it is given that you will be given a grid which consists of only two characters, that is dot and hash. There exists a whole Manhattan circle on the grid. Okay, there is actually a Manhattan circle on the grid. The top left, the top left corner of the grid has the coordinates 1 comma 1, and the bottom right corner of the coordinates has n comma m. Okay, this is the basic thing. Top this is when this is a grid, this is like this coordinate is nothing but 1 comma 1, this coordinate is nothing but n comma m, and it is given that there will be a entire circle on like entire Manhattan circle on this grid. Points a comma b belongs to the Manhattan circle centered at h comma k. Okay, circle some having at the coordinate h comma k, and the point, any point, let's say a comma b belongs to the Manhattan circle if mod of h minus a plus mod of k minus b less than r, where r is nothing but a positive constant. Okay, on the grid, the set of points that are part of the Manhattan circle are okay. Whatever the set of points that are the part of circle, they are marked with the hash. Basically, find the coordinates of the center of the circle. So basically, we need to find the coordinates of the center of the circle. That is nothing but h comma k. So During the contest, while I read this problem, I was also a bit confused while reading the problem. But once I saw the test cases like sample input and output, it was very clear. Okay, let's try to see the sample, whatever the examples that are given. Here, if you look at input format, first line will be number of test case. After that, n cross m grid will be given, having only two characters, dot and hash. For each and every test case, we need to print two integers, coordinates of the center of the circle. Okay, let's try to see the first example. Only circle is nothing but this one. So can I say that basically this will only be the center of the circle, which is nothing but 3 comma 3, I guess. And if you look at the sample output, it's 3 comma 3. Now, if you look at this one, second example, what is this entire circle? This is the entire circle. Yes or no? This is the entire circle where you are having two dots here, two dots here, one dot here, something like this. See here, hash I am having hash, here as well as hash, here as well as hash, something like this. Here hash is like whatever the circle is there, Manhattan circle, it is represented using the hash basically. Here again will be there, and we need to find this center of the circle. Now, what my initial thought was, can't I go row by row, find find the center one, find the center of the circle here. But after that, I realized that we do not have to do that as well. However, we just need to find the circle here. To find the circle, I just need this thing, this thing, and this thing. Yes or no? What are these four things? What are these four things? See, this entire thing will be a diameter. Yes or no? We want only the radius here, like not radius. This entire thing will be diameter. We want to find the center of the circle here. We need to find the what is the starting point of the circle. I can say uh, top here, left to starting point, right starting point, like right where it is ending, bottom where it is ending. Okay, top where it is starting, left from where the circle is starting, right where it is ending, bottom where it is ending. Once I get the top, bottom, left and right, okay, what is the top here? Top is nothing but the starting from the first row. Okay, I am taking here one based indexing because in the question as well it is given as the one based only. Now left, what about the left? What is the leftmost column where it is appearing? Nothing but the first column. Again, right, what is the end column where it is appearing? Nothing but the fifth here. What about the bottom? What is the bottom row where the circle is appearing here? Circle is covering bottom row where circle is being covered, nothing but 5. Now, how do I get the circle? Nothing, we need to find the center between this, we need to find the center mean. You know how to find the mean. Nothing by like, if I want to find the x coordinate, x is nothing but left plus right by 2, left plus right, left plus right by 2 will give you the x coordinate, and here top plus bottom, this thing will give you the y coordinate of the center of the circle, will give you the y coordinate. So it was just a like we need to make the observation here as well. If you look at each and every problem, like same thing here as well. Find this, like finding the top, left, right and bottom, then we can get the circle here as well, same thing. I hope the logic is clear. We are finding the topmost starting of the circle, bottom where the circle is ending, leftmost starting, rightmost ending of the circle. Once we get that, we are finding the x coordinate and the y coordinates of the circle here. X coordinate comma y coordinates of the center of the circle. Center equals to x coordinate comma y coordinates. Okay, so here how do we, now we need to see how do we find the left, like top, left, right and bottom. How do we find it? Simple, we can traverse in the entire matrix. and we can find the top, left, right and bottom. And if you look at the constants as well, here number of test cases 10 power 3. If you look at the n, it's not n comma n, it's like n cross n. If was something like n comma n, then we cannot traverse in the entire matrix as well, but here as it is n cross n, that means entire n cross n whatever cell is there, that would be 10 power 5. So once we can traverse it, so once while we are traversing, we'll be getting our top, left, right and bottom. Once we get it, we can get the x and y coordinates of the center of the circle as well. Let's try to code it. What all do we have in our input here? Okay, I'm having first n comma n is given. After that, first I will read n comma n. I can have a matrix of n cross n, but here I will be taking it differently. Let's take this as a 1 string. Okay, I will be taking it as a string. I will be saying int I equals to 0, I less than n, I plus plus. I will be reading them as a string basically. Push back s, that means I need a s as well. Okay, I'm considering each row as a string. Now once I get the string, what I told, we need to find the top, bottom, left and right. Okay, int top, int bottom, next int left, leftmost, and we need the right as well. You may have used this technique that whenever we want something initial point, like when we want something as minimum as possible, we declare with the int max. Same technique we'll be using here as well. We'll be declaring top as int max, bottom with the int min. I'll be declaring this with int min here as well. Int left equals to int max, right equals to int min, because I want to find the last point in the right side. Now I'll be traversing on the whatever the this is there input, and I plus plus. If my v of, I need to write this as well, int j equal to 0, j less than v of I dots, what I will be having in v of I, nothing but a string. So I will be saying v dot this thing like dot length, string length. Now if v of ij, when I will be all these things, when it is a hash, then only I will be doing all the, like whatever the x and y I need to update, I will update only when it is a hash. What all I need to update? If row, see, row is related with like x coordinate, which is nothing but left and right. So if x I is less than left, what I will say? I will say I will update my left with I here. Same thing bottom. If my I greater than right, I will say update my right with I here. Now y coordinates we need to look at, which is nothing but top and bottom. So if my j less than we want to find the as minimum as possible, so I will say j less than bottom. If j is less than bottom, I will update my, no, j less than top here, so I will update my top equal to j here. If j greater than bottom, j greater than bottom, bottom equal to j here. That's it, I guess. We'll be getting our xy like uh, top, bottom, left, right. Now from this I need to figure out my x and y coordinates for the center of circle as well. So I'll be calling, let's say, cx. How I will be calculating cx, center of circle x coordinates? Nothing but left plus right by 2, as we have discussed. Same thing with the cy as well, left plus right by 2. At the end I will be printing cx plus 1 because we need to represent in a 1 base indexing, cy plus 1. Okay, here I need to write the top plus bottom, I guess. Yeah, top plus bottom. Let's try to submit. What is the expected output? 3. Okay. Something we. Okay, here it has to be j plus plus. Same output we got. 3424. Submit it. Copy this. I will choose the fourth problem. I will paste it here. Submit. And it is accepted. That's it for the fourth problem. Okay, now let's try to see the fifth problem, that is secret box. In this problem, Tarsis has a box B with a side length x, y and z. It lies in the 3D plane, 3D coordinate plane extending from 0, 0, 0 to x, y and z. So here x, y, z is nothing but the length, height and width it represents. Now secret box X, he can place S somewhere within the B such that S is parallel to all the axes. For example, to better understand, we can take this picture example here. This is the box B, and this is the box S, or I can say the secret box. He can place secret box inside the box B anyway, such that few conditions are there. First condition, S has to be parallel to all the axes. Huh. What you mean to say is, whatever the secret box we are placing inside the box B, it has to be parallel to axis. It's not like something like we will rotate or do something and we will place it. We will not rotate. Every corner of S lies within the integer coordinates. Okay, he only wants to lie within the integer coordinates as mentioned before, not within the real numbers or negative. S is magical, the secret box is magical. So when placed at an integer location inside B, it will not fall to the ground. Okay, it will not fall to the ground, so we can place anywhere in the B. Among all the possibilities to choose the dimensions of X, S secret box S, determine the minimum number of distinct location he can choose to place his secret box S inside B. Okay, so he wants to determine all the or maximum number of distinct location he can place his secret box S inside the B. That's it. Maximum of distinct locations he can choose to place secret boxes inside the B. And here given that Tarsis does not rotate S once its side lengths are selected. He cannot rotate or do something once the sides are selected. uh, Problem is not that easy, but we will look at into it. Okay, he can place something like this, he can place it here, he can place it here. Like once the dimensions are fixed, he can place it anywhere he wants. Now let's try to look at few examples here. Okay, let's try to look at the sample here, whatever the example that is given. For the first is what is happening here? Dimensions of outer box. This is the dimensions of the outer box that is given 3 cross 3 cross 3. And this is nothing but K. This is nothing but K. What is K here? Volume of the secret box. Okay. This is the B box dimensions. Now we want to find a side length, like dimensions of secret box is such that it will give us the maximum possibility of arrangements. So here when you look at here first test case, it is optimal to choose side length S with the 2 comma 2 comma 2 as the volume of 2 comma 2 is 8, 8 and 8 matching. It can also show that there are 8 ways to put S inside the box B, and coordinates are also given. Coordinates are also given to you. Okay, before we figure it out, how do we find this dimensions of a sacred box X? Let's say there is box B. Okay, we are already having a box B. Its dimensions are also given to us, x, y, z. We also given some k. K is nothing but the volume of secret box. Volume of the secret box is given to you. Let's say I give you some coordinates a, b and c. Okay, I give you some coordinates a, b, c. Now I am telling you to find number of arrangements or number of ways to arrange this secret box S inside the B. How will you calculate that? Number of ways to arrange the secret box S inside the box B. Forget about how we are getting A, B, C and anything, like all these things. How will you get that? Number of ways. Number of ways or number of arrangements, how will you getting that? Can I say that number of ways would be nothing but x minus a plus 1 into y minus b plus 1 into z minus c plus 1. But how we are getting that? Like how we are writing x minus a plus 1? Okay, to explain you more clear, x is nothing but the x coordinates here. I will be taking the x coordinates here. Let's say there are length 5 I am writing here, 1, 2, 3, 4 and 5. This is x equals to 5, nothing but the length of the box B. Here length of the secret box is, let's say, something as 3. Okay, length is something as 3. Length of the secret box as 3. Now how many arrangements we can make here? Like how many ways are there to place boxes of length 3 inside the box of length 5? This is one way. Can I say this is one way? This is other way? Not this. This is one way. Other will be from here to here. Other will be from here to here. That means total 3 ways. That I will be getting from here as well. 5 minus 3 plus 1 will give you the 3 only. So that's why it is x minus a plus 1. This is for the x coordinates, same for the y coordinates, same for the z coordinates as well. Okay, same for the g coordinates as well. That means that if I somehow figure it out, like how to select ABC, we can solve this problem. But how do we now select ABC? How will we be getting ABC? We can try all the combinations for ABC here. Now, but if you look at the constraints for x, y, z, what it is saying, x comma y comma z can be 2000. Okay. What we thought? We thought one we can have a loop for A, one we can have a loop for B, one loop we can have for C. Yes or no? We are trying all the combinations. But in the constraint is given that x comma y comma z can be less than or equals to 2000. Now if I write 3 or nested for loop like this, what will happen? What will be our time complexity? Here I will be finding all these things, whatever the ways are there, all these things will be doing. So it will be nothing but something like this, yes or no? And this will be like 10 cube power 10 cube, which will be at the end 2 into, okay, this will be 8 because cube will be applied to 2 as well here, as well as 8 into 10 power 9. Will the 10 power 9 code will be accepted? No, right? It will give you the TLE. So somehow we need to optimize this. 10 power 9, we cannot check for all the possibilities. Now, once we cannot check for all the possibilities, can I say that, let's say if I am having the value of A, I am having some value of A, I am having some value of B. Do I even need to run this loop to get the value of C? Can't I get the value of C without running a loop? Here we need to use the volume. We can get it. Here we need to use the volume. What is mean by volume? That means A into B into C equal to K here. Yes or no? Yes or no? A into B into K. Volume formula. Length into width into height here, a into b into k. Now once I am having a into b, like if I want to find the c from here, what I would say, c equals to k by a into b. Now do you agree with me? Now I don't need a c for loop. If I'm having a ab value, if I'm having a k value, I'm having ab value, I'm having the k value, I can directly get the c value here. That means I can directly negate the here c for loop. And now my time complexity will be around 10 power 6. Yes or no? 10 power 6 to 10 power 7. Which will code will be accepted, yes or no? We are finding the c with the help of a, b and k. Now let's look at some constraints for the c as well. That means as we want only the integers part. If you have seen in the question, what is there, we want this whatever the xyz is there, okay, integer location, at an integer location, not a real number or something. Here also, when we read the test cases, what it was given? It was given that among all the determine the distinct location, he can choose to place secret box inside the B. Here also given such that all the side lengths are positive integers. Okay, okay, all the positive integers. Now to make sure that for c we are always getting a positive integer, like positive integer, first constraint for c would be k mod a into b has to be equal to 0. Then only I can say that when k divides by a into b, I will be getting an integer value. What is the next thing? Next thing could be, next constraint could be, when a divides by a into b, if it is less than or equal to z, I will consider this as c. C equals to this. When this condition is true, I will be considering k equals to, like c equals to k by a into b. Done. I am getting a value, b value, c value. Once I get the a, b, c value, I can get the number of ways as well. I can check for all the combinations. I can check for all the combinations. I will be getting the ways for each and every ways. From each and every ways, I can get the maximum answer as well. I hope the logic is clear. First, what we thought, if we somehow get the ABC, how we'll be getting the number of ways. Once we got to know how do we get number of ways, we thought of how to get ABC. We thought of trying all the three possibilities, like all the combinations, but that would give TLE. So we went for this thing. Okay, let's try to code up the what all we need to read here. Nothing but x, y, z. Along with that, we need to read k as well. So first I will be doing that. After that, what all do we require here? Like, let me take this as long. Now, once we take x, y, z and k, we need to go for each and every possibility, like try all the ways, selecting a and b. Okay, for that I will be saying, let's say a equal to 1, a less than or equal to z, or like x, a plus plus. Similarly, trying all the possibility for b as well, b less than or equal to y, b plus plus. Now c I need to find out of key what are the constants. If it is able, if we are able to divide, then only we will be doing it. K mod a into b equals to 0, and after that we will be taking the c. So same thing I will be doing. So first I will be checking if k mod a into b equal to 0 and k by a into b, if it is less than or equal to z, that means if it is fitting inside the box, secret box fitting inside the box, then I will be calculating the c here. C is nothing but k by a into b basically. Now c equals to k by a into b. Once this is done, now I need to calculate all the ways. I will be saying long ways equal to, how we will be finding the ways? Nothing but x minus a plus 1. Next, here I will be multiplying with y minus b plus 1. Next would be ways into equals to z minus c plus 1. Okay, we need the answer as well. Answer equals to store the maximum possibility here. Answer comma ways. So he initially I will be having my answer as well. Long answer equal to 0. Once this is done, I will simply print the answer here. I will run. Let's see the expected output. 825044. Okay, 852044. That's it. So I will try to submit it. Secret box. Still running. And it is accepted. That's it for the fifth problem. If you found this videos informative, do share with your friends. For more such content, do like, share and subscribe to our Smart Natives channel. Until next video, this is Ankit Patel signing off.